Alrighty, so for this video, we're going to go over the first section of the second exam that talked about derivatives. So we have about a set of 20 derivatives here, so we're just going to go over each step by step. So for the first one, the derivative of x is always going to be 1, because if we were to apply the power rule, so when we apply the power, we have x to the 1, and in this instance you bring down the 1 to the x, you'd have 1 times x, and then you have 1 minus 1, because you always subtract the initial power by 1, which in this instance would just give you 1 times x to the 0, which is just basically 1 times 1. So in this case it would just equal 1. And then over here, just like as I talked about before in the second one, it would just be, in this case, just 2x, because you're bringing down 2 to the x, and then you're subtracting 2 minus 1 in terms of the exponent, so that should just give you 2x. And then when it comes to the derivative of e to the x, that's its own special derivative, meaning that e to the x is always going to be e to the x, no matter what. So I could just correct that real quick. The power of e to the x is always going to be e to the x, and then the derivative of ln to x, you can always think of it in terms of 1 over x. That's just like the basic rule for it when it comes to derivatives of the natural logs. And then the derivative of 67, so the derivative of any constant is always going to be 0. So like no matter what number you have, you can have 67, you can have 1, or you can have 999,000. It's always going to be 0. And then the derivative of square root of x. So this is an interesting one, because what I like to do in this instance, what's easier for me, is usually I like to rewrite it. So I'll just do x to the power of 1/2, which equals to 1/2 x to the negative 1/2. So 1/2 times x to the power of negative 1/2, which in turn should just give you 1 over 2 times the square root of x, because since the square root can be defined by the power by the power of 1/2, you can just rewrite it as the square root of x. And since it's negative, and since you have a fraction, you want to move it into the denominator as a result. And then the derivative of 1 over x is just, once again, having the power rule coming in clutch. What I like to do is just rewrite it. So in this case, given that x is under 1 in the fraction, it's going to be negative x to the negative 1, which in turn it's going to be negative x to the negative 2, because you have the power rule. So you're subtracting negative 1 by 1, which gives you negative 2. So negative x to the power of negative 2. And since we typically want to rewrite the expression in terms of a positive exponent, we can just simply rewrite it as 1 over x squared, which should be the final one for this one. And then the denominator of 4 to the x. So this is more of an interesting situation in this cases, when you have an x as the exponent. What you can do, usually the formula for that is, if you have like b to the x, anything b to the x is just like ln of b times 4 times b to the x times the derivative of the exponent. So in this case, we'll just do, since 4 is the base, we'll just do ln of 4 times 4 to the x, and since the derivative of x is just 1, we'll just do it times 1. So it just, in this case, it would just be ln of 4 4 to the x. Just rewrite it as the I write it as an exponent. And then the derivative of x to the power of negative 99, or negative 99, so again, applying the power rule, you'd have bring down the negative 99. So you do negative 99x, and then you do negative 99 minus 1, which just gives you negative 100. And since you want to rewrite this to have a positive exponent, you would just write it as you would probably rewrite it as can do most likely 1 over 99x to the power of 100. Or you could just, no, that's probably, no, in this case, you would just do negative 99 over x to the 100, because you're rewriting this, so you're writing this as 1 over x to the power of 100, and then times negative 99 over 1, so that should just give you negative 99 over x to the power of 100. And then the denominator of pi to the x is just simply going to be pi, because the derivative of x is just 1, so this would just give you pi times 1, which just gives you pi in this case. And then the derivative of sine x, so looking back at our trigs and the trig formulas in relation to the derivatives, the derivative of sine x is always going to be cosine x, and then the derivative of cosine x is going to be sine x, negative sine x to be exact. And then the derivative of tan x in this instance is going to be secant squared x. And then again, looking at our trigs and going back to the derivatives, the derivative of the sine, the inverse sine can always be written as 1 over square root of 1 minus x squared. And then inverse of cosine, very similar approach. You just rewrite it as 1 over square root of 1 minus x squared, but this time instead of a positive, it's going to be a negative. And then the inverse of tan, again, looking back at the basic trig formulas and derivatives, it's going to be 1 over 1 plus x squared. Okay, and then looking back at logarithms or natural logs, so typically in these instances we have logs can be defined. You have the log base of x, which is always going to be written as 1 over x times ln of b. So in this case, b is 2. So we can just simply rewrite this as 1 over x times ln of 2, which gives us the derivative. And then the derivative of secant x is just secant tangent x. And then the derivative of cosecant x is just be negative cosecant x cotangent. And then just looking back at our basic trigs and formulas and their derivatives, the derivative of cotangent x is always going to be defined by negative cosecant squared x. That's it. Thank you.